Now we are going to talk about the chapter Thermodynamics. In this chapter, we are going to discuss laws of thermodynamics first. Laws of thermodynamics means zeroth law, first law of thermodynamics. Then the basic concepts of thermodynamics, isothermal, adiabatic process. What is the work done by isothermal and adiabatic process? Later on, we are going to talk about isobaric and isobaric process. Put together, we are going to talk in detail about Carnot engine. That is a heat. Right. Zeroth law of thermodynamics. Suppose we have three thermodynamical systems, A, B, and C. It has got a pressure, temperature, and volume. System A has got one pressure, volume, and temperature. System B, pressure, temperature, volume. System C also pressure, temperature. When A and B are in thermal equilibrium with the system C, A is thermal equilibrium with C, B is thermal equilibrium with C. Then by zeroth law, A and B are in thermal equilibrium with one another. Thermal equilibrium means what's that? Previously, we have the pressures V1, V1, temperature V1, V2, V2, T2, V3, V3. A and C are in thermal equilibrium. That means it will have a common pressure, common volume, common temperature. When you combine these two, how to combine that? Simple. This is the thermodynamic wall. System A, system C. Pressure P1, V1, T1. Pressure P3, P3. This is thermodynamic wall. Remove this wall. Same gas. Remove this wall. What will happen? Both the pressures, volume, and temperature put together will be P, V, and there is no question of P1, P2, P3, V1, P2, and T1, T2. So it is common now. Both the system possess same temperature, same pressure, and same. This is called zeroth law of thermodynamics. Fine. First law of thermodynamics. You are having a container with a frictionless piston. Some gas is present inside. Frictionless piston means by pushing it or moving up, you are not changing the pressure, volume, and temperature. That is called frictionless piston. By moving it, you are not doing any extra work. Frictionless piston. This gas molecules present inside the container possess some internal energy, dU. When you push the piston downwards, work is done on the gas. Correct? When gas is pushing the piston upwards, work done by the gas. You know the difference between these. Work done by the gas, work done on the gas. So, dU is the change in internal energy. Final internal energy minus initial internal energy. The gas molecules are not at rest, they are moving. When the gas molecules are moving, you can say kinetic energy. So kinetic energy and potential energy both together only we call it as internal energy of the gas molecules. Correct? The energy what you are giving, say dq or q, whatever it is the sum of two terms. Number one, change in internal energy of the system. Number two, work done by change in internal energy possess both kinetic energy and potential energy of the gas molecules. And work done means you are not keeping quiet. You are moving the piston downwards or gas is pushing the piston upwards. So you can say what? Work done by the system. Work done on the system. Some work is said to be done. So the first law of thermodynamics says the energy what we are giving is a sum of two factors. Number one, change in internal energy. Number two, work done by system. Clear? Fine. Isothermal process. Before going to isothermal process, what is called work done by the thermodynamic system? How to calculate the work done? Work done in thermodynamic system. So in this case, work done by thermodynamic system, W is equal to force into displacement, F into T. This is basic formula. Work done is equal to force into displacement. What is force, sir? Force by area, you call it as pressure. So force is equal to pressure into area 1. So I can write T into A into T. Area into distance is what? Volume. So I can write T into volume. P in total work done. dW which writes total work done. Integral dW is equal to integral P. Integral PW is equal to integral P. What is integral dW? W integral initial volume by right? So this is called work done in thermodynamic process. Any equation, whether it is isothermal, adiabatic, isochloric, isobaric, any process, okay, basic formula for work done is integral P in T. Graphically, how to represent? This is called an indicator diagram. Pressure and volume. Indicator diagram. It indicates the changes in pressure and changes in volume. So the name indicator diagram. Next question. Sir, you are taking a thermodynamic system where frictionless piston you have, whether you are doing compression or expansion. Compression means pressure increases. When you come, this is a container, you are compressing. Automatically, volume decreases, pressure increases. Expansion. See the case. Expansion means what? Volume increases, pressure decreases. So, work done when you indicate by a graph, you should tell whether it is an expansion or a compression. The expansion I want VI initial pressure, initial volume. I. After expansion, volume increases. What is this? Vf, final volume. At that moment, what is the pressure? Clear? No, sir. I need the graph. This is for expansion. I need the graph for compression. Same graph. Pressure versus volume. In the case of expansion, what you have done? Pressure decreases from this point to this point. Pressure has come down. Same thing. Change the arrow mark. What is this? Pi. What is this? Initial pressure is here. Final pressure increases. So compression means pressure increases. Volume decreases. See, this is initial volume Pi. This is final. So this is called indicator diagram, which indicates the changes in pressure and changes. So graphically also you can calculate, or integration method also you can calculate. Both possible. Integration method, you should substitute the value limit Pi Vf, initial volume final. Right? Okay. Keep this in mind. We'll go for isothermal. The word iso means same. Thermal means temperature, heat energy. Same heat energy. What is the meaning? Temperature is constant. Pressure and volume of the system changes, but temperature remains constant. That is called isothermal. PV is equal to constant. PV is equal to mu RT, or PV is equal to nRT. Mu, number of moles, what you are assuming for a given gas. nRT means Avogadro number. N is called Avogadro. Right hand side, all the quantities are constant, because what we have assumed, the pressure and volume of the system changes, but temperature remains constant. That is called isothermal process. Next, we are going to talk about equation for, that is, what is the work done by the isothermal system. We have to calculate the work done. We have a derivation. Sir, in the case of a container with a gas with a frictionless piston, how isothermal process can be explained? Two conditions you should satisfy. First condition, this is called the surrounding walls of the container. Process must be slow. Walls of the surrounding walls of the container is conducting or conducting walls. What is the meaning? Slowly you push down the piston. When you push the piston slowly, what will happen? Pressure increases, volume decreases. What happens to temperature? Temperature also increases, but the system is very slow. At that moment, the change in temperature will go to the surrounding because it is purely conducting walls. The increase in temperature will go to the surrounding. So what is the meaning? Temperature remains constant. No, sir. I am expanding the gas. I am expanding the piston, thereby gas is pushing the piston. In that case, how can you say? What will happen? When the gas is pushing the piston upwards, pressure decreases, volume increases, temperature should decrease. Expansion means decrease, but surrounding process is very slow. So surrounding heat energy definitely can come to the system. System temperature will not change. Here also temperature is constant. Expansion or compression, pressure and volume of the system changes, temperature remains constant. What is the concept here? Process must be slow, otherwise it is called as quasi-static process. QUA is quasi-static. Slow process, quasi-static. Temperature constant, pressure and volume. Fine. Next step. Work done by isothermal. Beautiful derivation. Simple. What is the work done formula? We have seen W equal to integral dt. For expansion, we are say for example, Bi. But PV is equal to mu RT. This is the formula. Mu number of moles for a given gas molecule or universal gas constant. Isothermal process, temperature is also a constant. T constant. So T is equal to URT by T. From this equation, I can write PV is equal to mu RT, T is equal to mu RT by V. Substitute this value here. What will you get? W is equal to integral Di to P of P. What is P? Mu RT by V. Mu RT by V. Correct? Mu RT, entire family constant. Take it out. What will you get? Integral D by V. We have studied in maths basic integration. V differentiation is dV. V is a variable. When you differentiate that variable, we will get V. X differentiation dx. V differentiation dp. That means if numerator is the differentiation of denominator, if numerator is the differentiation of denominator, then the answer is log of denominator. Integration basic formula might have studied. From that we are telling W is equal to U or V log V ln. Ln means natural log. What you are seeing in logbook is log to the base 10. This is log to the base e, otherwise known as natural logarithm. Limit vi. So what will it be? W is equal to Q or E logarithm upper limit minus lower limit. What is the upper limit here? Vf. Lower limit Vi. So log Vf minus log Vi. Log A minus log B. What will you get? Log A by B. Log A minus log B. Log A by B. Log A ln. So this is the final formula for work done in the case of isothermal. Simply mu or t logarithm Vft. Sir, I need to convert this in terms of log to the base 10. I want to see Vf and Vi value. When you are doing the problem, sir, volume 3 times than the initial volume. Pressure 5 times, like that and all they are giving me. You have to use logarithm value. Logbook only are going to use. In that case, natural logarithm will not serve the purpose. So you have to convert. How to convert? W is equal to U or T 2.303 natural logarithm to logarithm to the base 10 if you want to convert, multiply by 2.303. That's all. Log to the base 10. Simple. Knowing the values of mu or t, final volume and initial volume, work done can be calculated. I want to do by the graph there. Plot the graph. Already we have done. For expansion also we have done the graph. Comparison also we have done. Okay. How will it do? Pressure versus volume. Expansion. Initial volume, final volume, initial pressure, final ABCD. Example I am telling ABCD. You plot a graph, calculate the area ABCD. Area ABCD will be the work done. 5 values are taken. Initial pressure, final pressure. Initial volume, final. Like that, 5 readings. Plot a graph. Draw like this. Find out the area of the graph. That area and this value both are same. It is possible to calculate work done by graph as well as by calculation. This is called isothermal. Clear, Amma? So first part we have finished. Next we are going to proceed. Adiabatic. Adiabatic process. Next, adiabatic, the word says nothing is constant. Nothing means here what? Temperature. Temperature is not a constant. Pressure, volume changes, but temperature is not a constant. Suppose that you take for original example, container, the gas, frictionless base surrounding walls. Entire thing non-conducting walls, non-conducting base. So, two conditions for adiabatic process must be quick. You compress the gas very fast, or you allow the gas to expand. Gas is pushing the piston upwards randomly, maximum speed. Quickly, when you do, what happens to temperature? In the case of compression, temperature will increase. The temperature cannot go to the surrounding. Why? Walls are non-conducting. Previous isothermal example, what we have seen? Walls are conducting. Process is dead slow. So, external heat energy, internal energy, whatever it is, temperature remains constant. Whereas in adiabatic, walls are non-conducting. So the extra heat energy cannot go out of the system. When you expand, temperature decreases. External heat energy cannot come into the system. That means what? Temperature is not a constant. Pressure and volume, yes, temperature. That is called adiabatic. Walls are non-conducting. Isothermal process we have done. Equation PV is equal to constant. Here equation is PV power gamma is equal to constant. If gamma means ratio of specific heat capacity of gases. Already we have learned Cp and Cv. Gamma is Cp by Cv. You know very well. Cp minus Cv is equal to R. It is called the Mayer's relation. Always Cp is greater than Cv. So Cp by Cp is greater than 1. Nearly this value is 1.41, 1.42 gamma value. Okay, fine. Is there any other equation for adiabatic process? One equation is PV power gamma. Another equation. Yes, we have. PV is equal to mu RT. P is equal to mu RT by V. Instead of P, you substitute mu RT by V. What will happen now? P V power gamma. Instead of P, what I can write? Mu RT by V into V power gamma is equal to 1. Mu for a given gas, number of moles fixed constant or universal gas constant, that is also constant. Temperature is not a constant variable, so I can write T V power gamma. This V you take it to numerator, what will happen? V power minus 1 you will get I will get gamma minus 1. TV power gamma minus 1. TV, you can remember easy. TV power gamma minus 1 is a constant. That is also adiabatic process. Two equations we have. One is TV power gamma is equal to constant. Another is TV gamma minus 1 is equal to constant. Sir, I want to draw a graph. Same. What we have done in isothermal process, same concept. Draw the graph. Pressure, volume. adiabatic expansion. This is adiabatic expansion. Pi changes to Pf. Important difference between isothermal and adiabatic. Pi, Pf. Temperature is not a constant. There we have never discussed about temperature because it is a constant. Here, temperature is a constant. Ti, expansion, temperature decreases. This is expansion. Tf less than. No, the compression graph I need. Same P versus P. Same the arrow, that's all. Di, temperature Di. Pf, temperature. You know very well, compression means temperature increases. Increases with what? Tf. So this is adiabatic process graphical notation. Now we are going to derive the equation for work done due to adiabatic process. It is slightly different than isothermal. Please concentrate. So work done in adiabatic process, we will see now. Basic formula for work done. W is equal to integral PdV Vi to Vf. What is the equation? PV power gamma is equal to constant. This is the equation for adiabatic process. Just now we have seen. PV power gamma is equal to constant. So P is equal to constant by V power gamma. Constant by V power gamma. Instead of P, you substitute this value here. W is equal to integral Vi Vf. P is nothing but constant by V power gamma into dV. Take the constant outside. Integral Vi Vf. V power gamma take the numerator. It becomes V power minus gamma dV. Integration basic formula you know. What formula? X power n dx is x power n plus 1 by n plus 1. So W is equal to constant V power minus gamma plus 1 by minus gamma limit Vi. Constant by minus gamma plus 1 is nothing but 1 minus gamma. V power 1 minus gamma Vi to Vf. Constant by 1 minus gamma upper limit what? Vf 1 minus gamma minus lower limit Vi 1 minus. What is this constant we have kept? What is that constant there? PV power gamma is the constant. Substitute that value. W is equal to Pi power gamma is equal to Pf power gamma is equal to Because PV power gamma is equal to constant means what, man? Pi power gamma, PF power gamma, constant value. That is the thing we have discussed here. So W is equal to 1 by 1 minus gamma constant PF constant into DF 1 minus gamma minus constant DI 1 minus. What is that constant? This way. Substitute W is equal to 1 by 1 minus gamma. This is final. So I have to take DF power gamma. DF power gamma into DF 1 minus constant TI. TI means initial. What is initial? TI power gamma into BI 1 minus. Okay, now BF power gamma, BF power minus gamma cancels. BI power gamma, BI power minus gamma cancels. What is remaining? 1 by 1 minus gamma, BF A power m into A power n is A power m plus n. So A power m we are taking out. A power n and this one cancels. Similarly, Vi power minus gamma, Vi power gamma, remaining is Vi is there. So I can write Vi, we know. What we know? PV is equal to mu or T. Vi is equal to mu or Ti. PF is equal to mu or Ti. Substitute this value. W is equal to what will happen, ma? 1 by 1 minus gamma. PF, what I can write? Mu or TF minus PI, what we can write? Mu or TI. Mu or take it out. What will you get? PF. This is work done by adiabatic process expansion. Expansion means temperature decreases. So final temperature is less than initial temperature. So change this. When you change this, you get a minus sign. This also you change. What will you get? W is equal to more in gamma minus. When you put 1 minus gamma, gamma minus 1, you will get one negative sign. Inside out. This is work done by adiabatic. Slightly lengthier. So simple. The main difference between isothermal and adiabatic in this case, from the equations that we can see, temperature is not a constant. Temperature is a variable. Correct, Amma? Fine. Next. Isobaric process. Isobaric. Isothermal, adiabatic we have seen. Now isochloric. Isobaric. Isobaric means volume is constant, pressure is variable, volume is constant. Sir, what example we have for constant volume but pressure is changed? Pressure cooker. In the kitchen, what we are using, pressure cooker, follows isobaric process only. You are keeping something inside the cooker, you are closing. That means volume is fixed. Continuously, when you give heat energy, pressure is going on increasing. Pressure cooker is the best example. So, W is equal to here is graph pressure volume. Here you are telling volume is constant. Volume is constant. What is the meaning? See here. Volume is constant. Pi. Initial pressure, final pressure. What is this? The expansion. Same volume. Volume is not changing. Compression I want, sir. Pressure, volume. Same graph. Change arrow. What is this? Is Pi. So compression means expansion means in the case of expansion, pressure decreases. Pressure decreases means like this here. Pi. In the case of compression, pressure increases. Pi. Decreases means pressure decreases means expansion. Pressure increases means compression. Both the cases, volume is constant. No change. Pressure cooker is the best example. Now, work done I want to calculate the calculate. What is work done formula? Integral PdV. When you say integral PdV, volume is constant there. Volume is constant means what is the meaning? Change in volume is zero. Here, dV is equal to 0. So, W is equal to 0 here. No change in volume. So, no work done. So, whatever energy you are giving, it is nothing but change in internal energy only. Thermodynamics first law. No work done at all. Because work done is. Next, isobaric process. Isobaric process means pressure is constant. Volume changes, but pressure is constant. What example we can give? Any kitchen appliance when you are working with open lid, sambar, rasam, and all you are making. What is the meaning of open? Open means pressure constant because it is open only, no atmospheric pressure. Temperature increases, that is different. We are not talking about temperature. Pressure is constant. Volume decreases, increases. Change in volume. Pressure constant. Correct? So that is called isobaric process. So isobaric process. What is the graph? Pressure, volume. Pressure. Pressure is constant. Volume changes. Constant volume. What is this? Initial volume, final volume. Volume increases. What is the meaning? Expansion. Volume decreases. Work done we have to calculate. The previous case work done is 0. Here we have to calculate the work done because it is not 0. Please use that. What is work done formula? W is equal to integral PdV VI. This is basic formula for work done. But what we know, PV is equal to mu RT. P is equal to mu RT by D. Substitute W is equal to integral mu RT. This is change volume. So I can write take pressure outside because it is constant. Pressure is constant in isobaric process. So take pressure outside. Integral dV is V VI to VF, VF minus VI. This is the formula of work done. Sir, I want the substitute for this value. How will you substitute? V is mu RT by VF. So what is the formula? P VF minus P VI. What is P? U R T F. P is U R T by. So T. What is BF? U R T F by P minus. What is BI? U R T I. P cancels. U R constant. What is the value? TF minus. This is the work done for isobaric process. So 4 different things we have seen. Isothermal process. P into V is a constant. Pressure and volume of the system changes. Temperature remains constant. Adiabatic process. Equation for isothermal is PV is equal to constant. Second process, adiabatic. Pressure and volume of the system changes, but temperature is not a constant. 2 equations we have seen for adiabatic. PV power gamma is equal to constant one equation. Another TV power gamma minus 1 is a constant. Second. Third, isochoric process. Isochoric means volume is constant. Pressure, temperature, internal energy changes, but volume is constant. That is isochoric process. There, work done is 0 because volume constant means integral PdV becomes 0. No work done. Only internal energy. Example, pressure cooker we have seen. And finally, isochoric process. Isochoric process means what? Just now we have seen isochoric. Isobaric process. Isobaric process means pressure is constant. Temperature, volume, internal energy changes, but pressure remains constant. So equation wise, in the case of basic equation, work done we have pressure changes means pressure constant for expansion, pressure constant for compression. Example, any cooking vessel, open lid. Lid is closed means isophoric. Lid to open means isothermic. Correct? Work done formula WPdV. Just now we have seen pressure constant. So we have taken pressure outside. V initial volume final. Vf minus Vi. Mu RT basic equation. PV is equal to mu RT. V is mu RT by V. Instead of Vf, I can put mu RTF final temperature minus Vi mu RTI. V get cancelled. So the equation is mu RTF minus Ti. So work done by isothermal formula mu r gamma minus 1 Df minus T. For adiabatic isothermal means work done is 2.303 RT log D2 Df by this is isothermal and this is adiabatic equation work done. Isophoric work done is 0. Then isobaric work done is mu or Df minus. So next class we will do heat engine, Carnot engine, then refrigeration. Thank you. We continue.